It's a pleasure being here. Glad to be able to speak for a little bit. Let's get the slides up. This is the title of the talk. It's more or less what Myron said it's going to be. My point is simply that you have to deconstruct it because it's an element of propaganda. Much of what you've heard is really misinformation and sophistry. It's the usual propagandistic issue of repetition, getting endorsements by a variety of means. And in particular, and I'll emphasize this at some point, widespread ignorance is not entirely what I'd like to focus on. It is the absence of any intellectual critical faculties to deal with logic. Statements are made which do not make sense, but they ride. Now, none of this would matter much except that all sorts of proposals that are expensive and dangerous are being promoted to deal with this alleged problem. So it behooves us to analyze what's going on carefully and to learn a little bit about climate to see why some of these things don't fit. I'll begin with the business of how the issue is manipulated. And here you should understand from a historical perspective, this is nothing new. This is at the very origin of this issue. Already in the 1970s, there was open discussion of how climate change would be an excellent vehicle for a variety of agendas. One of the people espousing this was a man called Bert Bolin. He was trained in meteorology, but he actually left meteorology per se in the 50s. He returned to Sweden from Princeton, and he immediately got active in politics and was an advisor to the Swedish Prime Minister, and later became the first head of the Intergovernmental Panel on Climate Change. Once the issue emerged onto the public arena, I mean, this was around 1980s, late 80s, within the 90s, two institutions were formed. They're very interesting, and they're worth probably looking at in their own right in a lecture. They have an interlocking directorate. They really are functioning as one institution. One is in England, the Tyndall Centre for Climate Studies, and it's at the University of East Anglia. And the other is the Potsdam Institute for Climate Impact Research in Germany, outside of Berlin. The latter is headed by Hans-Joachim Schellenhuber, who's apparently very close to Merkel. And the English is headed by Michael Hulme, although, as I say, they both play an active role in each other's institutions. These institutions, in many respects, epitomize the exploitation of this issue, and their members and their large institutions constitute numerous participants in the IPCC. Now, recently, Hulme came out with a book, rather remarkable book. It's called Why We Disagree About Climate Change. Now, within this book, he readily acknowledges that the science is uncertain, but he concludes that this doesn't matter given the importance of possible impact and the uses to which the issue may be put. Here are some quotes from this book. The idea of climate change should be seen as an intellectual resource around which our collective and personal identities and projects can form and take shape. We need to ask, sort of paraphrasing Kennedy, not what we can do for climate change, but to ask what climate change can do for us. Because the idea of climate change is so plastic, it can be deployed across many of our human projects and can serve many of our psychological, ethical, and spiritual needs. We will continue to create and tell new stories about climate change and mobilize them in support of our projects. These myths transcend the scientific categories of true and false. Well, nicely put. As always in propaganda, repetition is an important tool. One could always refer to Joseph Goebbels' famous remark, but I prefer Lewis Carroll in his poem, The Hunting of the Snark. Just the place for a snark, the bellman cried, as he landed his crew with care, supporting each man on the top of the tide by a finger entwined in his hair. Just a place for a snark, I have said it twice, that alone should encourage the crew. Just the place for a snark, I have said it thrice. What I tell you 3 times is true. Anyway, he had the picture in the 19th century. Another tool of propaganda is the idea of a conceptual picture. The Spanish philosopher José Ortega y Gasset had this pithy remark, create a concept and reality leaves the room. In the case of global warming, the concept appears to be that CO2 is increasing, that CO2 is a greenhouse gas, where greenhouse warming is analogized to a blanket, whose addition should lead to some warming, and that there has been some warming. Whence follows the illogical conclusions that CO2 has caused the warming and that the warming will be dangerous. The co-optation of science turns out to be an easy matter. And that's the disappointing thing to realize. It's happened many times. Personally, I have noticed, clearly in Nazi Germany and fascist Italy, academics were the first to support anything that was demanded of them. I've detailed this in a publication, but what is interesting is how well President Dwight David Eisenhower understood this. In his farewell address, which is famous for his remarks about the military-industrial complex, he had some other remarks. He gave a warning that public policy could itself become the captive of a scientific technological elite. And the reason is partly because of the huge costs involved. A government contract becomes virtually a substitute for intellectual curiosity, and the prospect of domination of the nation's scholars by federal employment, project allocations, and the power of money is ever present and is gravely to be regarded. Now, of late, polls are showing in both the UK and in the US that substantial majorities no longer regard global warming as serious. And in England, the Times reported that the Foreign Secretary, David Miliband, was responding to this. He accused the public yesterday, this is actually October 23rd, not a few days ago, of lacking a sense of urgency in the face of potentially devastating consequences of climate change. David Miliband said that people had grown apathetic about the issue and they needed to be galvanized into action before the Copenhagen Climate Change Summit in December. Now, Benny Peiser has a news group on the internet, and he couldn't resist putting in this Bertolt Brecht response to the popular uprisings in East Germany in June 1953. After the uprising of the 17th June, the secretary of the Writers' Union had leaflets distributed in the Stalinallee stating that the people had forfeited the confidence of the government and could win it back only by redoubled efforts. Would it not be easier in that case for the government to dissolve the people and elect another? Bertolt Brecht was a communist, but he was not imperceptive. Anyway, here's the last of these. This is from last spring, the Claremont Review of Books. For those of you who are not familiar, this is a conservative version of the New York Review of Books. And the article here, The Wilderness Years Begin, is discussing the conflict within the Republican Party between traditionalists and reformers. This would normally be a rather specialized interest, but on the next page, he refers to David Brooks, who was writing in the New York Times and discussing the difference between reformers and traditionalists. And talking about reformers, I noticed this remark. They tend to take global warming seriously, according to Brooks, not only on the merits, but in the belief that conservatives cannot continue to insult the sensibilities of the educated class and the entire East and West coasts. Is this really the situation? At least as far as the president of my institution goes and our nation's science advisor, it is. Last spring, there was a symposium on energy at MIT. Our president, Susan Hockfield, introducing the symposium, spoke of climate change as accelerating. She has since repeated this many times. I asked her privately what basis she had for this claim, sending her the following figures. This is the famous temperature chart. I should explain what it is. The horizontal axis is time in years. The vertical axis is temperature anomaly. And essentially, the units are 0 in the middle, a ½ degree down, a ½ degree up. So it's not a big range. And even in this, which is commonly shown, acceleration usually means increasing rate. Even here, it's not obvious. Moreover, the axis was, 1 degree peak to peak, less than that. It represented a change somewhere around 3/4 of a degree in a century. Now, here is an item that appears daily in the Boston Globe. I like this diagram very much. I use it with undergraduate students. Essentially, every day they show, let's see, is pointer in here? No. Oh yeah, here. Each day they show this blue. That's the range from from the low to the high for that day. And then the gray, the darker gray, is the average high and low for the day. And the light gray is the record high and low for the day. And it goes back 30 days. So you see how it changed over the month. And you see a number of things. This is for April 2008. So you see in the month of April, the temperature is, of course, increasing as we go from winter to summer, through spring. We see that the temperature is fluctuating. On the whole, it's not very far from the average highs and lows. And then the record highs and lows, they only tell you what year they are for the previous day, but in this particular chart, the high was in 1974 and the low was in 1909. Now, in the middle of this chart is a red line. And the question is, what is its significance? And the significance is simple. The thickness of that red line represents the total range of global mean temperature anomaly in the previous diagram. Just to put it in perspective. It is negligible compared to the change of temperature over April. It's negligible compared to the range of temperature in any given day. It is, no place. And yet, you look at this chart, and we'll see later how it's treated. Anyway, this is it again. Now, let me go backwards a moment. Okay. Let's spread this out since 1985. Now, I should mention to you, I mentioned before, it's on the slide, what this pink fuzz is. The pink fuzz is the way I represent the error bars. Instead of a bar, I have fuzz because that's really the way it behaves. It gets less likely the further you get from something. And now we'll focus on 1985 to 2008. And the point to keep in mind, don't worry about sophisticated analyses of trends and this, is it going up, is it going down? There's no point to that for a short record. What is relevant is any two temperatures where the pink fuzz overlaps are not statistically significantly different from each other. And by that criterion, 2008, and probably I would guess 2009 in a couple of months, will not be statistically significantly different from 1987. To speak of that as accelerating is bizarre. Now, on the other hand, here's how the BBC discussed this. They said they finally have acknowledged temperature has not been doing much in a long time. Indeed, for the whole period, practically, when this issue has been around. And so they went to some skeptics to see, they were saying, some people say it doesn't mean anything, it's just a hiatus. We'll see later, it means a lot. Skeptics disagree. They insist it is unlikely that temperatures will reach the dizzy heights of 1998 until 2030 at the earliest. It is possible, they say, that because of the ocean and solar cycles, a period of global cooling is more likely. This is nonsense on all sides. The thing that is ridiculous is the use of the phrase dizzy heights. Look at the numbers. We're talking about 1/10 of a degree. And yet the language speaks to something totally different. It's a little bit like every day in the financial reports, you have the Dow Jones, it went up 1 point, looks the same as though it went up 1,000 points. This is popular misinformation, but commonplace. Of course, when you tell people this, they'll say, but what about Arctic ice? And, somebody prepared this nice diagram. And each color is a different year, starting 2003 to 2009. And what we see is in 2000, it's a seasonal thing. You have a lot of coverage in the winter. It's reduced by, 70, 80% by the summer. And that small amount can fluctuate quite a lot. And so in 2007, you had a drop from 5.5 to 4.5. And so you could say there was a 20% drop in the minimum, which is not a very reasonable way to describe it, but it sounds big. And then slow restoration over the next 2 years. When I show this to an enthusiast of global warming, they always say, well, why are you starting only in, which date is it here, 2001. The data went back to 1979. The curve I had didn't go up to 2009, but here's what you have for the Arctic sea ice, and that illustrates it quite nicely. In the winter, you have about 15 million square kilometers. In the summer, typically you have 5 or 6. The seasonal change dominates it. And then not much was going on, but there was a dip here, both in the winter and then a little bit later in the summer. You don't mention the winter one because, it's only 1 out of 15, so that's not 20%. But 1 out of 5 is 20%, so it sounds bigger. And besides, if you go to the southern hemisphere, there's nothing much going on at all, although, again, the skeptics of global warming like to point to one of these being record-breaking ice cover in the summer, but, we're talking about negligibilities. On the other hand, the anecdotal stuff can be much more dramatic. So even though on the diagrams not much is going on, here is a statement. The Arctic Ocean is warming up, icebergs are growing scarcer, and in some places the seals are finding the water too hot. Reports all point to a radical change in climate conditions and hitherto unheard of temperatures in the Arctic zone. Expeditions report that scarcely any ice has been met with as far north as 81 degrees 29 minutes. Great masses of ice have been replaced by moraines of earth and stones, while at many points well-known glaciers have entirely disappeared. This is a much more dramatic remark, but for this. It's from the U.S. Weather Bureau, 1922. In fact, the Arctic is notoriously variable in this sense. At any rate, President Hockfield graciously replied to my question without, as usual, answering it. Here's her reply. That said, I take from your note a strong statement that climate change discussions be grounded in science rather than being politically driven, and on this matter I agree wholeheartedly. In consultation with MIT's Center for Global Change Science, which is not really its center, our comments about climate change reflect the last IPCC report, the best available consensus of the world's climate scientists. Of course, the science must always be open to thoughtful challenge as more observations and analysis accumulate. Now, it's important to notice here, she has not looked at the IPCC report. She went to someone who has a funny little program, and they said it was in the IPCC. But in fact, the IPCC report did not claim change was accelerating. But Hockfield's response does reveal something very characteristic of the current presentation of this issue. Namely, any and every statement is justified by an appeal to authority rather than by scientific argument. You'll see Holdren say, how can so many societies all approve of this if it isn't true? And he avoids any discussion of the science. In fact, the last time I've heard this was last Friday. President Obama did exactly this at MIT. On the one hand, he was calling for sound science and critical analysis. On the other hand, he was calling for the marginalization of naysayers concerning global warming. It is, as an aside, an appalling feature of the present environment that this kind of abuse of scientific integrity is conducted to cheers at universities. Universities as such provide virtually no defense against this kind of behavior by important officials. Gore did it all the time. He would call scientists who he disagreed with to testify in front of the managers of all the funding agencies, so they knew who he was against. At any rate, be that as it may, Hockfield was followed by John Holdren, the president's science advisor. And I have some slides from the MIT podcast of the event. I've enhanced them so that the text is clearer. It was a meeting on clean power, building a new clean energy economy. And John Holdren began with insights from climate science. Climate change is happening faster than previously predicted. Emissions, concentrations, temperatures, and sea level are all rising at or above those of earlier IPCC high scenarios. Significant harm to human well-being is already occurring. We can no longer avoid dangerous human interference. And science is emerging that tipping points into disastrous conditions could occur sooner rather than later. Interestingly, none of these statements is true, at least as concerns anthropogenic warming. To be sure, CO2 is increasing, but that does not constitute climate change per se. 100-year sea level projections, for the IPCC is 1.26 inches for 10 years. It's not readily distinguishable from the change that has been occurring since the end of the last ice age. I have a colleague at MIT, an oceanographer, Carl Wunsch, who's noted, and look at the contorted language. This is sort of interesting in its own right. It remains possible that the database is insufficient to compute mean sea level trends with the accuracy necessary to discuss the impact of global warming, as disappointing as this conclusion may be. This is his conclusion. Why is it remains possible? Well, part of the reason is Carl is very much a supporter of Obama, and he by and large supports global warming alarm. And you'll find this throughout the literature. People try to keep their science straight, but don't wish to drop the issue. What was at issue in Carl's work is they have satellites now that measure geopotentials of sea surface. And it goes up and down irregularly and frequently, and usually by far larger amounts than we're talking about when we talk about mean sea level. Most coastal regions have large changes in sea level, which, remember, usually is measured by tide gauges, which are showing the relative height of the sea to the land because of land changes due to tectonics. At any rate, there's also no physical basis for suggesting tipping points. Forget that they're becoming more likely. I mean, Holdren engages in a semantic trick by saying they're becoming more likely. He is making you think they're a normal part of the picture and everyone agrees on it, but they may not have been so likely, now they're more likely. Nobody's ever even suggested this, a mechanism for this. I mean, there have been some suggestions, but they don't amount to anything. And moreover, tipping points, even in systems where they exist, are never characterized by systems where you have diminishing returns. It's usually where something, is escalating and finally you go over some limit. CO2, the impact of every added amount is less than its predecessor. What we see again is the tendency for any claims to be made once the basis for the claim need only be authority. And this is an interesting twist on this. That is to say, once people regard authority as a sufficient argument, then you're free to make any claim you wish, especially if you're in high government office, refer to authority. The authority frequently doesn't say what it is claimed to have said, but any advocate in high office can rest assured that some authority will come along to assent. One of the most beautiful examples we've seen lately is a whole bunch of professional societies, most completely unrelated to geophysics, but two related, send a letter to the senators of the U.S. Warning about all the dangers of global warming, and the IPCC says, and science demands, and so on. None of this is in the original documents. Somebody told them what they were supposed to say was in the original documents. They then add their authority to it, and the authority becomes what is quoted. Same thing when Susan Hockfield says it's accelerating. Next thing you'll know is they say the president of MIT says it's accelerating. So it's a kind of funny chain letter thing. In any event, continued with the next slide. Climate change impacts already happening. Then it has monsoon changes, lead to agricultural impact, extreme precipitation, more floods, change in temperature to reduce precipitation some places, increased drought other places, soil drying, fires, and so on and so forth. Goes on. He backed off some of them because there were people present who might have objected. Quite apart from the fact that climate is always changing, and such changes have consequences, Holdren's statements are sometimes even untrue, but even when they are true, they're unattributable to anthropogenic warming. The consequences cited, moreover, depend on the confluence of many factors besides global mean temperature. So, for instance, you have the lower graph here. If I can get this. This is just temperature for northern hemisphere. And here you have the percentage of the U.S. experiencing drought conditions. In this case, we see no evidence of correlation at all. On the other hand, crop yields for wheat and corn both have increased as temperatures increased. But, while there would appear to be correlation, we know there are many other reasons why crop yields happen to be increasing. And this is where logic comes in. When it comes to unusual climate, which always occurs someplace, most claims of evidence for global warming are guilty of something called the prosecutor's fallacy. In its simple form, it runs as follows. For instance, if A shoots B, with near certainty there will be gunpowder evidence on A's hands. On the other hand, in a legal proceeding, this is often flipped, so that it is argued that if C has evidence of gunpowder in his hands, then C shot B. The odds of that are negligible. Now, in global warming, it's much worse. Essentially, the line of argument goes as follows. For instance, if A kicked up some dirt, leaving an indentation in the ground into which a rock fell, and B tripped on this rock and bumped into C, who was carrying a carton of eggs, which fell and broke, then if some broken eggs were found, it showed that A had kicked up some dirt. And this type of argument is presented time and again and referred to as science. What really is the claimed IPCC consensus, and how was it arrived at? It certainly wasn't arrived at by a show of hands. It was a small committee that proposed it, and in fact, even the executive summary does it, summary for policymakers, doesn't quite say it this way. This is the press release. In fact, I used to think it was unfortunate with the IPCC. They wrote 1,000 pages, and it was summarized in only 13 pages, and that's all anyone read. So I realized no one read the 13 pages. They only listened to the press release, which was about 2 lines. And this is it. This is the press release. At any rate, this hardly constitutes a basis for concern. Remember, we looked at the numbers. We're talking about a few tenths of a degree, and this is saying 51% or more. So, why would you get worried over this? At any rate, even this, though, how was it arrived at? What was done was to take a large number of models that could not reasonably simulate known patterns of natural behavior. These are things like El Nino, Pacific decadal, Atlantic multicadal oscillation. Claim, nonetheless, that such models accurately depicted natural internal variability, and use the fact that these models could not replicate the warming episode from the mid-70s through the mid-90s to argue that forcing was necessary and that the forcing must have been due to man. Why? Because they couldn't think of anything else. There's a remarkable line of argument. I mean, what is the point? Why do I underline this? Because in any time you're attributing something, you're obligated to show nothing else could have caused it. Now, in this case, we know of other things that they didn't represent right, so they couldn't have shown that. But even if you succeed, it's a poor line of argument because it's an argument from ignorance. Basically says, anything else I can think of. And it's exactly the type of argument that is criticized, even though it's better prepared in the defense of intelligent design. So here you have intelligent design attacked for using this type of argument. You have the same argument used in support of global warming, and here it's put forth as being demanded by science, whereas in one of the other case, I think appropriately, it's being put forward as in contradiction of science. Equally ironic, the fact that global mean temperature anomalies ceased increasing by the mid-90s is acknowledged by modeling groups as contradicting the main underlying assumption of the so-called attribution argument. That is to say, if you have a period that does not behave the way warming suggests it should behave, it means there are other processes going on that are as big. If there are other processes going on as big, you cannot make the attribution. And yet, the attribution continues to be made as dogma. Indeed, American scientists, editors, said to me that to suggest that that attribution is wrong is completely equivalent to declaring Einstein's theory of relativity is bunk. Now, that's a degree of debasement of science that's very impressive. Now, all projections of dangerous impact hinge on something called climate sensitivity. As I mentioned, the projections of catastrophe depend on a lot else besides. But the interesting thing about the equilibrium response to doubling CO2, which is the usual benchmark, is they haven't changed since 1979. What they've done then and do today is take models, run them with doubled CO2, and see the range of response. The models will give you a response from 1.5 to 5 degrees, and that's put down. Now, I would actually say the range is 1.5 to infinity. But whoever heard of science where you have a model and you test it by running it over and over again? It addresses nothing. Moreover, why is it with the billions of dollars spent on climate science that this range hasn't been diminished? Now, it turns out, data is the way you usually check calculations. And here I'll mention something Myron mentioned. I have details here and papers on it, but in fact, we have the data, have for some time, to measure the greenhouse effect, to see if it is functioning as predicted directly from the data, and to evaluate climate sensitivity. What we have is data for outgoing radiation. This is from 2 satellites, ERBI, Earth Radiation Budget Experiment, and CERES, which is cloud something or other. And they give you the long wave emitted by the Earth, the heat radiation, and the reflected short wave. We also have sea surface temperatures for this period from essentially our Weather Bureau, NCEP, National Center for Environmental Prediction. And on top of that, you remember the IPCC intercompares models. So they have a data set of the models that were run with exactly the same temperature we observed. They forced them with that, where they predict what radiation you should see at the top of the atmosphere. So all this is available. This is the sea surface temperature going back. Red is incidence of increasing temperature, blue decreasing. Here you have the satellite visible light and infrared. Here the black graphs are the results of each model for the outgoing infrared radiation, and this is the visible. I'm not going to dwell on the details. There are formulas you can look at for the feedback routine. Let's not dwell on this particularly. If you want, we can go through it further. But the interesting thing about it is most feedbacks in models and in nature are occurring in the tropics. In the tropics, counter to what one might think, the zero feedback response to changes in radiation, changes in temperature, is almost zero in radiation because of opacity and other things. So if you're measuring in the tropics and you see changes in outgoing radiation with temperature, that's all feedback. Now, what do I mean by feedback? Let me pause for a moment. It's generally acknowledged that if all you do is double CO2, you get about 1 degree. The models, as we saw, got 1.5 to 5, or infinity, I would argue. The reason they have that is they have what are called positive feedbacks. All predictions of significant warming require that the main greenhouse substances in the atmosphere, clouds and water vapor, or main radiative substances, act to amplify anything man does way above what man does by itself. This is not widely recognized, but what you can do is see how the fluctuations in radiation change with temperature. And from this, you can evaluate the feedback and the amplification. Now, remember, essentially, we're thinking about the greenhouse effect as a blanket. So if increasing the temperature reduces the outgoing radiation, which is the cooling of the system, then your blanket is being amplified. If, on the other hand, the outgoing radiation goes up as you change the temperature, it means you're thinning the blanket rather than thickening it. Okay. These are the model results. The horizontal axis is temperature. The vertical axis is outgoing flux. And we see for every model in the IPCC, the blanket is thickening. And by the current logic or illogic of science, the fact that all models agree is used to imply that the result is robust. It is the same from model to model. But in this instance, we have data to compare with, and that's what it looks like. Instead of going down, it goes up, and it goes up, if you check the numbers, by twice the magnitude that it goes down in the previous ones. You can easily relate this to sensitivity. This is a graph that shows that. And what happens is you find the models all lie on a part of this graph which is nearly horizontal. That is to say, they're near what's called instability or regeneration. And so in this range, you cannot tell the difference between 1.5 and infinity. There's very little distinction. Any uncertainty in the outgoing radiation would leave you uncertain to that. But when you come to nature, you're in a part of the graph, which is almost vertical. So it's very insensitive to uncertainty. It's going to give you about 0.5 degree for a doubling of CO2, maybe 0.4, maybe a little more. But that's the range. Maybe 0.6 if you have something going on in mid-latitudes. So essentially we're saying the sensitivity of climate, if you took 5 degrees, it's 1/10 what the models predict. That's usually where people say catastrophe is on the books. Even where the models say not much is on the books, this is saying nature will give you even 1/3 of that. Okay, in a normal world, I think what we've just seen would say that the very foundation of the issue of global warming is wrong. So where do we go from here? And it's hard to tell, given that to note this constitutes an insult to the sensibilities of the educated class and the entire East and West Coast. Thank you.
Thank you, Dick. We have time for questions, and the drill is I will pick you out, and then our Jose here from CEI will come with a microphone, and please tell us who you are and your affiliation before you ask your question. So the first question is J.J. Brown.
Hi, I'm J.J. Brown with Senator Hatch. The question is, your work on this basically goes to the question of sensitivity. How does the positive negative feedback? And I've seen similar results coming from Christie's work. I'm just wondering, what's the difference between what you've done?
Christie doesn't work on this. You're talking about Spencer.
Roy Spencer is what I'm talking about. I'm sorry.
Yeah.
And he did his
related to clouds, but what's the real difference?
There have been a lot of papers coming out. There have been various ones. We had a paper on the iris effect. Roy is probably looking at that. In other words, he's looking mechanistically how clouds change. And this is different from that in that it isn't looking at mechanism, it's looking at the final result directly.
similar result, though.
Oh, yeah. We had a similar result in 2000.
So
I mean, you know.
You're looking at data out of the satellites of what's actually coming out of the atmosphere, the flux. He's looking at sort of what the impact of clouds would be.
He's looking at clouds per se.
Yeah.
And we were looking at clouds per se and other things in 2000. These are mechanistic studies. This is looking at sensitivity directly.
In the back here.
Hi, Mike Shahanian with Senator Sessions' office. There's a lot going on right now in the Arctic in terms of navies from different various fleets staking out claims to resources there, projecting that it's all going to be, there's going to be a lot of open sea that's ready for drilling. And the U.S. is talking about having more icebreakers, for example, to patrol up there, and there's going to be sea lanes to trade directly with potentially Europe and Russia. What do you think about that? Are those all going to be mistakes and wasted money?
Hard question. Depends on how good the icebreakers are. No, I mean, as I say, this has been reported many times. The Antarctic explorer Amundsen actually did traverse the Arctic Circle many, many years ago. The atomic submarine Thresher surfaced at the North Pole in the 70s. You know, it's not unusual there's a year when a ship can go through. But this year some attempted it and they had to be rescued. It's an iffy business. So far, no one, I think, would be advised to depend on it for more than 1 year, and that year at random. You know, in other words, but drilling techniques, that's another story. You know, drilling through ice is not that big a challenge.
Sam Casman.
Sam Casman, CEI. Professor Lindzen, it seems when you've got some entrenched belief and then you have a growing amount of data and studies contradicting that belief, you have more scientists flowing from those who once held the belief to disowning it as compared to those who go the other way. Do you have an idea what the pattern has been when it comes to scientists who profess to believe in global warming alarmism?
I think you're not realizing what's going on. The field is corrupt, without any question. I would say most scientists don't believe this and didn't believe it 20 years ago. But for young scientists, they know they're in trouble if they say it, so they don't. I get all sorts of email. I mean, I just got invited to speak for Mike McElroy's, a symposium. And they're asking me to speak on this stuff because, the students are aware of it, but they can't bring it up. You have all sorts of people, who are not in the field. You've created a community of scientists who are not interested in the science. You notice the institute in Potsdam is called the Institute for Climate Impacts. Do you know what that means? It means if you're studying cockroaches and you want funding, you call it global warming and cockroaches, but never in a million years do you learn about climate.
I'd like to clarify my question. If you look at scientists who have publicly staked out a position, my question is, let's say it's scientists who have publicly professed to be global warming alarmists over the last decade. A number of them, it seems to me, have now actually gone to the other side, whereas of scientists who have been publicly identified as skeptics, you find very few becoming believers in alarmism.
Yeah, I think that's true mostly, but it's, you're missing the point. When you see Wunsch's statement there, okay, you realize he is expressing doubt, but he's careful to cover his rear end. You have another person like my colleague Kerry Emanuel. He doesn't particularly believe in it, but boy, it's helpful to go along with the flow and try and keep your stuff on hurricanes from not being too polluted. How do you describe these people as being for or against? It's meaningless. They're opportunistic.
Yes, the first.
Graham Madigan, Congressman Hinchy's office. I noticed you mentioned a thinning of the blanket so-called, due to radiation of heat from the Earth's surface, I believe? Or
The blanket is the greenhouse stuff. The radiation from the surface is what is trying to cool the Earth against the heating by the sun. So if sun's beating down, the Earth is cooling by radiating, and then the blanket inhibits the cooling so it gets warmer, just like putting a blanket on at night, cold night. Prevents you from losing heat. Okay. John?
John Quapis, the Virginia Coalition for Common Sense on Climate Change. It seems to me, Doctor, that what we're facing today is a situation similar to Galileo, where this establishment at his time refused to look at the growing body of facts on the issue that was up at that point. But my real question to you is, what do you see as the 2 or 3 key points that need to be made in this argument, and how do you have any suggestions on strategy or tactics to be able to break this conventional wisdom within the media?
It's a tough question because, to be fair, for instance, I did this work with a postdoc, okay? Young Sung Choi, he's from Korea. He's looking for work. I would like this stuff to be known, but I don't want to overstate anything, and everything in science has its own question marks, because it'll jeopardize his career opportunities. The answer to this is unfortunately one that Aaron Wildowski gave 15, 20 years ago before he died, which is the people who are interested in the policy, and we all are to some extent, but some people like you is the foremost, have to genuinely familiarize themselves with the science. I'll help. Other people will help. But you're going to have to break a certain impasse. That impasse begins with the word skeptic. Whenever I'm asked, am I a climate skeptic, I always answer no. To the extent possible, I am a climate denier. And that's because skepticism assumes there is a good a priori case, but you have doubts about it. There isn't even a good a priori case. And so by allowing us to be called skeptics, they have forced us to agree that they have something.